Well, a few years ago, I was watching the news and a woman came on the TV, really distressed because the house had been flooded. Not once, not twice, but 3 times. That stayed with me. I couldn't understand why she'd been flooded 3 times, so I thought there must be an easier, affordable way to stop water coming into your house. So I knew that the solution would be a hinge that slides, a lateral hinge that moved, which allowed the door to go back and then close and a parallel fitting. So I looked on the internet for a lateral hinge. There wasn't one, so I designed one, and that's how it started. I had proof of concept for flood and reduced carbon emissions, but not for fire. That's what I needed, proof of concept for fire, because it's one thing getting proof of concept for flood and pouring a bit of water on the door, and if it spills you mop it up, but it's another thing trying to set fire into it in a room with a confined space. That's where I2C came in. I was invited to join the program. We did the experiment, it worked. They brought the vision that I had to life in a practical way so everybody could see it. It needs to be a controlled environment, it needs to be done safely. So that's what I2C did for me, something that I couldn't possibly have done. They're brilliant at getting your idea and getting what it's all about. So the I2C program for me personally has been brilliant. What I like about the program is how they get your idea and how they bring it to life. It's all about prototypes. Everybody wants to see something physical and see how it works. And I have that now. And I have proof of concept for fire and for flood. The hinge has been designed to be simple and affordable. It's no good having a great design, a great product, if it's not cost effective. I always thought it would be the ultimate fire door. As an added bonus, when the door is closed, it's energy efficient. So it's probably the first energy efficient green fire door.